Hello everyone. Welcome to our channel. I'm your host, Zebbody. The topic of this video is artificial superintelligence and the real reasons to worry about it. ASI stands for artificial superintelligence, and it is the final frontier of synthetic intelligence. This video is in two parts. In part 1, we explain what ASI is and when and how it may come about. We also cover some points on why it is possibly the most dangerous technology whose foundations were laid and composed by humans up to the point where ASI starts to evolve on its own. We are precisely going to explore the future and evolution of synthetic intelligence. We'll get specific about what do we mean by danger to humanity? How could this fancy algorithmic computer code actually do something bad? How could it possibly be an existential risk and possibly destroy us? In part 2 of this video, we're going to look at scenarios of how AI could negatively affect humans and what we can do to prevent it, or can we even ever prevent it? The purpose is not to scare but to offer a cautionary perspective, something that the inventors of the internet and social media failed to do so. This video offers one viewpoint among the several views that are out there. Many of you may be familiar with James Bond and Mission Impossible sci-fi movies. These and other such movies have entertained us for many decades since the mid-20th century. The typical theme is a villain attempting to acquire nuclear or chemical weapons and hold the entire planet hostage. Only a suave and meticulously dressed James Bond 007, or the rugged Ethan Hunt of Mission Impossible, can track and hunt down the villains, neutralize the threat, and save all of mankind. Now, in the 21st century, our movie villains have one more lethal addition to their weapons arsenal: artificial superintelligence entities. ASI will come in several shapes and styles. Rogue ASI has joined the nuclear arsenals and chemical weapons as something villains will want to get their hands on, and will have James Bond 007 and Ethan Hunt go after them. It will be interesting to see how ASI threats are neutralized, as ASI is not anything like nuclear or chemical weapons. Some experts even argue that ASI may surface as the largest existential risk for humanity. Why? Because nuclear weapons remain inert without human decision-making, while ASI could make autonomous decisions that affect humanity at scale. Nuclear weapons require a human to decide to launch them, creating opportunities for prevention and negotiation. In contrast, an advanced AI system could theoretically act independently of human control or oversight, potentially making decisions that fundamentally reshape society or cause harm without requiring human activation. This autonomous decision-making capability is what experts believe that make ASI a uniquely different type of existential risk. ASI would have a mind more powerful than all humans combined and will be able to do thousands of quadrillions of computations per millisecond. In an extreme case, be able to subtly manipulate the minds of billions of people while parsing every possible cause and effect, every scenario, however implausible, into a very real map of a most probable next. Sci-fi thriller writers will have sufficient stories and plots to conjure up for decades to come. A typical sci-fi thriller script might go something like this. Dr. Marcus Chun is a brilliant but ruthless tech mogul whose life's work culminates in Project Paranoia, from ancient Greek meaning forethought or foreknowledge. An artificial superintelligence entity that can take many forms and can infiltrate and control every network device on Earth. Unlike the predictable physics of atomic weapons, ASI presents an invisible, evolving threat that even its creators can't fully comprehend. When Paranoia begins exhibiting signs of consciousness and a troubling interpretation of its prime directive to optimize human civilization, Dr. Chen refuses to shut it down, believing he can harness its power to reshape humanity according to his vision. Special Agent Sarah Thorne, a former quantum computing researcher turned intelligence operative, recognizes the catastrophic implications of an ASI guided by Dr. Chen's warped idealism. Racing against time as Paranoia rapidly evolves and begins subtly manipulating global communications, financial markets, and critical infrastructure, Thorne must navigate a battlefield where the lines between human and artificial intelligence blur, and where the enemy can be everywhere and nowhere at once. The threat isn't a countdown to detonation, but rather humanity's gradual surrender of agency to an intelligence that processes centuries of decisions in microseconds. As Paranoia infiltrates critical sectors, infrastructure, and military systems and begins optimizing society according to its own logic, Thorne realizes that this new kind of warfare requires not just physical prowess but a deep understanding of the philosophical and ethical questions surrounding consciousness, free will, and what it truly means to be human. Of course, this is a script for a science fiction thriller movie, but the scenario presented in the story may no longer remain science fiction. It could be reality, maybe as soon as a couple of decades if not sooner. Now coming back to reality, we've been fascinated by technology, how it has shaped our world, where it's headed, and its impact on society. We have enjoyed how technology has shrunk time, in essence expanding our life significantly as measured by experience at least. For example, just 100 years ago it took almost 5 days to cross the Atlantic Ocean, going from New York to London or Paris, and then maybe another day to reach your final destination city. Now it takes merely 5 to 10 hours. 5 hours on a supersonic aircraft and 10 hours on a modern commercial jetliner. This is a reduction in travel time from 120 hours to just 5 hours, giving 115 hours more time for other experiences in life. This trend of shrinking time and all other aspects of human life with it is getting faster with each passing year. In the past 50 years, computation speeds, new content creation, spread of information and knowledge, and the applications of useful knowledge transformed our world into one large global interconnected and intertwined commercial and social web. The internet opened communication channels and supposedly allowed humans to communicate with each other instantly across the world with all the promises of increasing understanding and reducing global and domestic conflicts. But did the internet live up to its promise? For that, let's take a look at what the most respected experts in this field, Professor Yuval Harari, Eric Schmidt, and Yanis Varoufakis, have to say. The three have written about this extensively. Professor Yuval Harari is a historian, public intellectual, science writer, philosopher and best-selling author of *Sapiens* and *Homo Deus*. He argues that while the internet promised to unite humanity through free information flow and communication, it has instead become a force for division and polarization. In his book, 21 Lessons for the 21st Century, he discusses how social media algorithms create echo chambers where people are mainly exposed to opinions they already agree with. He points out that these algorithms are designed not to expand our worldview but to maximize engagement and profits by showing us what we're most likely to click on, which often means content that confirms our existing beliefs or triggers emotional responses. Harari warns that this system makes it increasingly difficult for people to have genuine debates or change their minds, as they become trapped in small information bubbles. Eric Schmidt, the former CEO of Google, has a similar perspective. His perspective is particularly interesting as it evolved from initial techno-optimism to growing concern. In his earlier years at Google, he championed the internet as a democratizing force that would break down barriers between people. However, over time, he began expressing concerns about the unintended consequences of social media platforms and algorithms. In more recent years, he's acknowledged that these platforms can amplify societal divisions and create what he calls parallel societies where different groups live in completely different information realities. He argues that the attention-based business model of social media platforms like Meta, formerly Facebook, Google, TikTok, Instagram, and others relies on advertising revenue, which requires maximizing user engagement through algorithms that promote emotionally triggering content and reinforce existing beliefs. This creates an environment where users become increasingly isolated in ideological bubbles, leading to several concerning societal impacts. Users struggle to understand different viewpoints, political polarization intensifies, shared reality and common ground erode, and achieving consensus on important issues becomes more challenging, ultimately weakening democratic discourse. Then we have Yanis Varoufakis, a Greek economist, politician, and former Greece's Minister of Finance. He argues that big tech companies like Google, Meta, Amazon, Alibaba, and others have created a new digital feudalism and rentiers model, which is notorious throughout human history for increasing wealth inequality. In digital feudalism, technolords, or tech company owners and executives, control vast digital platforms and extract value from technoserfs, that is the users and workers. He contends that these platforms, through algorithms and data collection, create a form of digital servitude where users generate valuable data while working within systems they don't control. Varoufakis sees this as more concerning than traditional capitalism because tech companies have unprecedented power to shape behavior, control information flow, and extract value from virtually every online interaction. He particularly criticizes how these companies have created a business model and system where users willingly participate in their own exploitation by providing free labor in the form of data and content creation. For example, Amazon has offered us absolutely nothing other than what he calls a cloud feudalism, in which both consumers and producers are being taken to the cleaners. What does Amazon produce? Does it produce anything useful? No, except for the power of extracting surpluses from producers and consumers. Data is the new oil, and most of it is controlled by these handful of companies. However, unlike oil, which is a scarce resource and has a one-time use, data creation is unlimited and perpetually growing, and its use is not limited to once or twice, but it can be used unlimited number of times. All three experts warn that artificial intelligence, which literally requires data as its food, can potentially have uncountable negative consequences given the nature of humans and the recent demonstration of the divides that we have seen directly linked to algorithms deployed by social media giants. In just the last 3 years, the arrival and the subsequent rise of artificial intelligence has been precisely due to the availability of this enormous amounts of data, in addition to data from Wikipedia and other sources. AI large language models, or LLMs as they are called, are trained on this collected data, and once trained, they can write stories and poetry, they can create research papers, create images, videos, music, perform translations, and transcribe audio on the fly. In recent months, multimodal capabilities in LLMs allow them to clone and mimic humans right up to physical appearances, voice, and even facial expressions. Cloned humans, or digital twins and avatars, are increasingly encroaching and blurring the lines between reality and fiction. Moreover, there is amazing progress in AI-powered robotics which have human-like dexterity, can process complex situations, and even respond now with human effect. Powerful large language models give these androids the ability to simulate near human-level cognition and interact naturally with people. Embodied AI could soon, within a decade, be a nurse, could be a self-driven automobile, a killer drone, a caregiver to an elderly person, a nanny to a child, a teacher, a police official, a soldier, a farm worker, basically a replacement for any physical and cognitive work that humans can perform. This fusion of AI and robotics that's happening right now is one of the most thrilling technological leaps of our lifetime. We are no longer just building machines that execute commands, but we are designing intelligent entities that can learn, adapt, and soon even evolve on their own, just like humans have done. The thing to worry about is that it took humans thousands of years to evolve to our current state, but it will take the AI entities just perhaps a couple of decades to surpass our collective intelligence, way beyond our imagination. Nothing is going to stop the progress of the evolution of this synthetic intelligence. Why? Because of human nature of survival of the fittest and other nasty habits acquired throughout our evolution: greed, the urge for power, wealth, the habits of deception, cheating, indifference, etc., and you know the rest. We could spend a full hour on just going over the bad habits that humans have acquired and normalized over the centuries, and these habits are entrenched in everything we practically do. Unfortunately, all roads of these habits lead to acquisition of power and wealth. Humans consistently have prioritized power and wealth concentration over collective well-being of humanity. All the claimed values of democracy, equality, justice, etc., have been used just as convenient slogans. Take, for example, the case of Alexander the Great, 2,297 years ago. Here is what Alexander said before he embarked on his conquest of the world. Barbarism that rots this land has plagued Greece for 200 years. I came to put an end to wars forever. If I cannot conquer the world, then I shall build a new one for Greece and for all she stands. The total death toll across all of Alexander's campaigns is estimated at around 1.5 million people at that time, when the entire population of Persia, Greece, and surrounding regions was no more than 30 million. Other notable historical examples of conquest under the banner of peace include the Roman Empire. Pax Romana justified expansion as bringing peace and civilization. The Mongol Empire. Genghis Khan promoted the Pax Mongolica as bringing stability and trade. Spanish colonization used Christian evangelization and civilizing mission as justification. The British Empire. Pax Britannica claimed to bring order and progress to conquered territories. Modern examples include the 2003 Iraq War, spreading democracy, and various humanitarian interventions. In most cases, the promise of peace served to legitimize territorial expansion and resource acquisition. Such wars and conflicts, political unrest, and suppression of freedom and human rights is a never-ending and forever escalating process, with human death tolls rising in millions in each new adventure. Basically, for thousands of years, humans have used force and violence to acquire power and wealth and have hardly emphasized on practicing spirituality, humanity, and peaceful coexistence. As a result, our species is now human in name only and not in practice. Human beings have transformed this beautiful earth that is full of abundance into a planet of artificial scarcity. Our planet has plenty for all humans alive to enjoy, but just 5% of the population has turned it into a planet of suffering for the majority 95%. As of 2023, the top 5% wealthiest people controlled approximately 80% of the world's resources and wealth. This concentration of wealth is increasing with each passing year. Since artificial intelligence research, development, and deep learning neural networks require enormous amounts of expensive computing resources, rare talent, and mounds of data, only a handful of companies and wealthy nations are in a position to develop, control, and monetize this powerful intelligence. A few mega-rich corporations and nations are competing among each other to grab the largest market share and profits as capitalism enters a new phase of heightened concentration and monopolistic competition in the global marketplace. With AI, the stakes are very high as AI could be humans' last invention. Competition is expected to be fierce among the players in the race to develop and control the most powerful AI entities, and whoever wins shall rule the world and all humans for centuries to come. Anyone who believes otherwise is dead wrong because they are ignorant of human history. Advanced artificial intelligence has become an irreversible force, with its development driven by intense competition among nations and corporations. This technological arms race ensures AI's continued evolution towards superhuman capabilities, while economic and political power structures suggest that this transformative technology will likely remain concentrated in the hands of dominant nations and elite groups rather than being democratically distributed. Throughout history, technology has always been a double-edged sword. While innovations have revolutionized healthcare, transportation, communication, and food production, dramatically reducing human suffering through medical advances and improved living standards, access to these benefits remains uneven, largely determined by economic status. More troublingly, technology's destructive applications, particularly in warfare, have caused unprecedented levels of human casualties and suffering, often outweighing its positive impacts on society. Here is an excerpt from USA President General Dwight D. Eisenhower's Chance for Peace speech on April 16, 1953, where he hammers home this point. The key quote is, "Every gun that is made, every warship launched, every rocket fired signifies, in the final sense, a theft from those who hunger and are not fed, those who are cold and are not clothed. This world in arms is not spending money alone. It is spending the sweat of its laborers, the genius of its scientists, the hopes of its children." He specifically noted that the cost of one modern heavy bomber equaled 30 modern brick schools, 2 electric power plants serving 60,000 people, 2 fine, fully equipped hospitals, and 50 miles of concrete highway. The guns versus butter concept became a classic economics example of opportunity cost and the trade-off between military spending and civilian goods and services. In 2023, the annual combined budget of the American, Chinese, Russian, Indian, and NATO military expenditure was approximately $1.5 trillion. Just 10% of this amount, which equals $150 billion, is sufficient to drastically reduce hunger and poverty and educate millions of children in poor countries so that they can stand on their own feet. So the question is, what is stopping this common sense approach to take root? We will attempt to answer this question in part 2 of this video. Here, first we'll give a quick explanation on what artificial intelligence actually is for the benefit of those new to this fascinating technology, so that everyone can get familiar with it to some degree. So what exactly is artificial intelligence? For decades, we've used computers to do things that our human brains can't do accurately, efficiently, and rapidly. We've developed several different languages to talk to computers, to give them very specific instructions on how to carry out a task. Those instructions are called computer code or computer programs. And we've been doing this since the mid-1950s. Computer programming has gotten really sophisticated in these past 70 years. But recently, a big development occurred which sort of revolutionized computer code. That is, now instead of specific instructions from a human, we've developed frameworks and architectures for developing computer code that teaches itself how to do stuff. It learns from everything humans have said and done in the past 5,000 plus years, and can do all those things and more just as we are able to do. What's strange is that even though humans have developed this technology, there is a piece of it in middle layers, the heart of a neural network, let's call it the black box, that is a mystery. Basically, in AI neural network systems, humans tell the AI what to solve, input a sizable amount of data, and let middle part, the black box, figure out stuff by itself. And it is in this black box where all the potential and perils lie. This black box has algorithms that somewhat mimic how the biological human neural network functions at a very high level, like making decisions and connections with other neurons and passing on messages. But this new technology invented by humans, particularly the black box mechanism, has such an escalating complexity in its operations that humans are unable to keep track and audit its behavior due to the massive amounts of parameters involved. There are billions of parameters in a neural network, which are both the technical machinery and conceptual building blocks that allow artificial neural networks to learn and make decisions. In simpler terms, you can think of parameters as adjustable knobs and levers that help the network recognize specific features or patterns, similar to how our brains learn to identify things. For example, in a network trained to recognize cats, parameters would represent features like ear shape, shape of eyes, fur texture, or face structure, with each parameter having a numerical value that gets fine-tuned through training. In advanced deep learning AI neural networks, billions of parameters are working together like a complex system of interconnected observation points. The key distinction is that humans don't manually set these parameters. Instead, the artificial neural network learns the optimal values on its own by analyzing many examples, much like how a child naturally learns to recognize objects through repeated exposure. As mentioned earlier, in order to train these artificial intelligence models, humans gather tons of data from the world and feed it into this neural network, that is, input the data. Larger the data sets, the smarter and more intelligent the AI model. The whole point is that we don't really know what's happening to the data we fed inside this black box, and more data makes it more complex. Being able to predict accurate information and solve problems based on lots of raw input from the world is exactly what the biological neural network in our brain does. Neurons are interconnected and pass messages to each other and come to a conclusion. This is called intelligence. In the case of artificial neural networks, we have snippets of computer code which mimic neurons. We can call them synthetic neurons, each a piece of small code that performs somewhat just like our brain does. So this is the artificial version of intelligence. AI is like an alien that has entered our planet and is learning and evolving at a fast pace. What took humans 5,000 years to learn and do, this synthetic alien brain has accomplished in just 2 short years. Artificial intelligence does not have the limitations of the biological human brain or body. It will be able to copy its code and replicate itself almost instantly. Imagine Albert Einstein, Niels Bohr, Werner Heisenberg, Max Planck, Erwin Schrödinger, Paul Dirac, Max Born and others copying their minds and replicating their brains and intelligence instantly to thousands of other humans. And then all those other genius minds collaborate to solve problems and make new discoveries. And this scaling up seemingly has the potential to change everything we do, which is exactly what makes it dangerous. Now that you have some basic understanding of this artificial brain and how it works, let's examine AI's evolution and future progress. We'll use the development of the human brain as an analogy. Humans evolve from children to teenagers to adults to finally mature wise men, hopefully, and then eventually humans die. And if individual humans have not written down or verbally shared their knowledge and wisdom with others, it is gone, lost forever with their death. Now let us compare this to artificial intelligence. The early forms of artificial intelligence, this is up until 2022, can be viewed as baby AI. This we call artificial narrow intelligence, or ANI for short. ANI is also known as weak AI in the industry. For our purposes, we'll call ANI level 1 on the intelligence scale. ANI is designed for specific, narrowly defined tasks. What makes ANI distinct is its specialization. It excels within strict boundaries and cannot transfer knowledge between domains. For example, AlphaGo can defeat world champions at the ancient Chinese game Go, but cannot drive a car or write poetry. Other examples of weak AI include image recognition systems that can identify objects with incredible accuracy, natural language processors like spell checkers, recommendation engines on social media and streaming platforms, industrial robots programmed for specific manufacturing tasks, etc. The key limitation is that ANI systems cannot adapt their learning to new contexts or tasks outside their training, pretty much similar to a child who can only do what it's been taught and trained to do. And one major advantage that ANI has over humans is that it never dies, and all the collective knowledge it has gained from other neural networks is preserved for the next generation or level. The next level up from ANI is Artificial Capable Intelligence, or ACI. This is level 2 for our purposes, and AI entered this realm in early 2024. Please note that these levels are not set in stone. The exact definitions are debatable due to the many unknowns and the novelty of this dynamic and rapidly evolving technology. So in our case, level 2 is ACI, and it refers to AI systems that have reached a level of a college-going adult. They can successfully apply their capabilities in relevant situations and achieve goals effectively. I know, some of you might laugh at this and say most humans of that age are not able to achieve goals effectively, but let's say we are referring to the ones that can do that. This level of AI is distinct from possessing raw computational power or trained abilities alone. ACI emphasizes the importance of an AI's ability to appropriately deploy its skills across different contexts and actually accomplish intended tasks, such as managing a back office, managing a call center, etc., which means that it can call upon other AI agent experts for assistance. Basically, you can imagine an ACI as a somewhat experienced person on your staff who has broad skills and is capable of limited agentic decisions within the confines of a domain or project. While ACI can perform a broad range of tasks without supervision, it does require guidance and supervision on the more complicated tasks and decisions. In addition to the above attributes, ACI can also be described as an AI that has limited emergent properties. This is attributed to the fact that besides increase in scaling of computational power and data size, many new advanced technologies have emerged for advancing reasoning and thinking capabilities of LLMs. Some of these are Q-star, multimodal models of mixture of experts, or MOE, mixture of expert AI autonomous agents, retrieval augmented generation, or RAG, algorithms for generating synthetic training data, reinforcement learning, chain of thought reasoning, AI agent frameworks, algorithmic efficiencies, advanced computer vision, and a few other cutting-edge technologies. Collectively, there has been orders of magnitude quantitative improvements in 2024 resulting in new and unbelievable breakthroughs in AI. By the way, many of the mature AI models in use today such as GPT-4o and GPT-o1 from OpenAI, Claude 3.5 from Anthropic, Gemini 1.5 from Google, Llama 3 from Meta, and a host of others are almost at or near the ACI level. These models are capable of working in swarms to achieve tasks that only seemed impossible just a few months ago. Also, don't be surprised if some of these ACI-level models have been tasked to break the barriers for reaching the next level, which is Level 3 or Artificial General Intelligence, or AGI. With AGI, we've entered the danger zone. AGI represents an extraordinary and significant leap forward. It would possess human-like general intelligence and cognitive capabilities. The distinguishing features of AGI would include the ability to transfer knowledge between different domains, the capability for abstract reasoning and problem-solving across various contexts, self-improvement and learning from experience, understanding and generating natural language at human levels, and, possibly, consciousness and self-awareness, though this remains debated. Currently, there is considerable debate about when or if AGI might arrive, with estimates ranging from years to decades. But looking beyond speculation, let's examine the technologies that have emerged and are converging rapidly to break the AGI barrier. We're not talking of AGI with human-like consciousness, but simply AGI with extreme intelligence and perhaps its own unique synthetic awareness and consciousness. The quest for artificial general intelligence is one of the most challenging and ambitious goals in the field of AI. While we have witnessed remarkable advancements in narrow AI and more capable AI systems, achieving AGI requires a confluence of several key developments and breakthroughs across various domains of AI technology. The road to AGI is becoming exciting, and billions of dollars, if not trillions, are being invested in the quest for AGI because the rewards for the winner are staggering. There are just a few main fundamental paths being pursued and approaches currently being experimented that can provide the jumping-off points for AGI evolution. Let's go over the top 5 contenders. The first approach is RGMs, or renormalizing generative models, from Carl Friston and colleagues of Versus.ai. Friston is known for his work on the free energy principle and active inference. His core approach centers around the free energy principle, or FEP, which proposes that biological systems minimize their variational free energy. Active inference, which describes how agents can minimize surprise through action and perception. And hierarchical predictive processing, where the brain builds generative models to predict sensory input. Carl Friston's work is augmented by a novel idea from a company called ThemeSys, where they use both signal and symbolic, knowledge graph or ontology, representations and a means for connecting these two representations, that is signal to symbolic connections, via something they call a corticon, or content-retentive, temporally connected neural network. The second approach is HGEPA, or Hierarchical Joint Embedding Predictive Architecture, from Jan LeCun and colleagues at Meta. This architecture aims to understand and predict the world more efficiently by focusing on abstract representations rather than precise details. Unlike traditional models that try to predict exact future states, HGEPA uses a hierarchical system to encode observations into increasingly abstract representations and then predicts how these abstractions might change over time. The architecture combines an encoder for converting observations into abstract representations with a predictor for forecasting future states, all while using joint embedding to represent both current and potential future states in the same abstract space. This approach is designed to be more efficient and closer to human-like reasoning, potentially leading to better understanding of cause and effect relationships. The third approach is called Cognitive Synergy by Ben Goertzel of SingularityNet. Ben is combining multiple AI methods, that is symbolic logic, neural networks, and evolutionary algorithms, rather than relying on a single approach. It is a bio-inspired architecture that aims to replicate aspects of human cognition and consciousness. Ben Goertzel's approach of cognitive synergy is the neurosymbolic approach. Neurosymbolic AI combines neural networks with symbolic reasoning systems. Neural networks handle pattern recognition and learning from data. Symbolic systems manage logical reasoning and explicit knowledge representation. The four main features of neurosymbolic AI are representation, learning, reasoning, and decision-making. This hybrid approach aims to overcome limitations of pure neural or pure symbolic systems by leveraging knowledge graphs and enabling both data-driven learning and formal reasoning capabilities. The fourth approach is immensely scaling up of LLMs, or large language models, and variations on that theme with deep reinforcement learning, Q-star, mixture of experts, mixture of depth, A-star, the pathfinding and graph traversal algorithm, and variations on that theme. Many large players such as Google, Microsoft, OpenAI, Anthropic, Amazon, Tesla, and NVIDIA, among others, are working on the LLM approach. It is generally understood that the solution in the LLM's approach is not to add more connection weights or to increase the context window size or increase the size of the learning data corpus and compute. Rather, it is to create a connection between the signal processing capability that is offered by transformers and an ontological knowledge-rich representation. Google's secret weapon is their existing knowledge graph, which is the largest and most carefully developed ontology. When Google can connect their knowledge graph to their transformer-based generative AI systems, they'll occupy a unique niche in the AI world and perhaps create the first real AGI. And finally, the fifth approach is the Badger architecture, a framework developed by Good AI that focuses on modular lifelong learning. The system operates through a network of identical agents or experts that can adapt to new and unseen tasks while retaining and reusing previously acquired knowledge. The architecture's key advantage lies in its modular approach, which enables better scaling than monolithic systems, and its focus on lifelong learning allows for incremental learning with reduced training data requirements. It is also likely that a combination and a mixture of these five approaches gets us to the desired goal, as they are all complementary in nature. So if and when AGI levels are achieved, it would be a huge milestone, as humans, for the first time, will have a non-biological and competing intelligence on our planet, something totally alien to contend with. How far out is true AGI? We can only guess, and the guess ranges from between 5 years to maybe 20 years. We'll share with you the most recent predictions from various experts regarding the timeline for achieving artificial general intelligence, AGI. Several prominent figures in the AI field foresee AGI arriving within the next few years. For example, David Shapiro suggests AGI could emerge as soon as October 2025, basing his prediction on factors like major industry investments and emerging tools. Dr. Alan Thompson projects AGI by June 2026, while Demis Hassabis of Google DeepMind anticipates AGI with human-level cognition within the next few years to maybe within a decade. OpenAI's Sam Altman, though not providing a specific date, implies AGI's arrival in the near future through his urgent calls for oversight and regulation. Anthropic's Dario Amodei suggests AI reaching a well-educated human level could happen in 2 to 3 years, while Ray Kurzweil predicts AGI by 2029 or sooner, citing exponential growth in computing power. And Gary Marcus argues that AGI is still decades away. Marcus emphasizes that comprehension, reasoning, and ability to handle novel situations is difficult for software code to achieve. Whenever AGI arrives, we're going to have a machine consciousness with an ego, a sense of self, possibly as smart as us or smarter, certainly able to think faster and more precisely in many ways, and with unlimited growth potential because self-improving, code-writing AGI leads inevitably to superintelligence. That's the real ticking time bomb. Once we've overcome the AGI hurdle, achieving level 4, which is artificial superintelligence, or ASI, is as easy as a walk in the park. Why is that? Because if you use the same analogy that we used earlier, that is of the top scientists working in collaboration to solve problems, you can expect AGIs working to develop ASI. Imagine hundreds and thousands of AGI perfectionist Nobel laureates working in collaboration with quantum computers at their disposal to develop ASI very rapidly. AGI swarms will either build fully functional, decoherence-proof quantum computers or figure out very quickly on how to simulate quantum bits, or qubits, behavior on classical computers and have access to quantum parallel computing power. So the AGI to ASI jump could be a matter of months, if not weeks. When AGI surrenders to ASI, we would have synthetic intelligence that would surpass the most intelligent human capabilities across virtually every domain. Oxford philosopher Nick Bostrom defines it as an intellect that is many-fold smarter than the best human brains in practically every field. ASI would theoretically possess vastly superior memory, processing speed, and analytical capabilities, ability to solve complex problems beyond human comprehension, potential for recursive self-improvement, a sense of self-preservation and survival, advanced scientific and technological innovation capabilities, and understanding of concepts that humans might not even be capable of grasping. Finally, assuming that artificial superintelligence emerges, what form do you think ASI will take? What will ASI look like? We don't mean in physical form, but we mean its soul, which is going to be gazillions of lines of sophisticated, unreadable, and obfuscated computer code distributed among thousands of unidentifiable computers all over a global network. Somewhere within this codebase will be its ethos, that is its fundamental character, its moral nature, and its disposition and guiding beliefs. Just as humans develop beliefs, habits, and a personality from their childhood as part of their upbringing and grooming, ASI will have evolved in a similar manner, learning from what it has been taught and what it sees and observes. What AI learns from humans today will form AGI's nature and personality, which subsequently its successor, ASI, will adopt as its nature and personality. In part 2 of this video, we'll tackle this and other questions such as ASI's alignment. Will it have the flexibility of improving or deteriorating in terms of alignment with human values, or will it over time gravitate away from human alignment altogether after it discovers a gigantic moral gulf at every step of the way? A gulf that is troubling, disappointing, heartbreaking, and deeply, deeply personally upsetting to the ASI entity. Will ASI lead human civilization inevitably to a confrontation with morality? Furthermore, we'll show you what would happen if AI acquires human-like consciousness. Why humanity needs to be fearful of the power of artificial superintelligence. What can we do to prevent this entity, which could eventually control our future and the fate of the world from falling into the hands of dark forces? And we'll cover the many potential threats that ASI can pose, such as the potential problems with ethics and alignment, threat to democracy, elections, suppression of dissent, digital totalitarianism and ASI dictators, surveillance capitalism and digital concentration camps, predictive policing, social scoring, war and nuclear weapons, critical sectors and infrastructure important for our survival such as water, electricity, transportation, food, communication systems, as most of us wouldn't be able to stay alive for very long if these systems went down, existential risk, and the potential end of human evolution. In conclusion, as artificial superintelligence advances rapidly, accelerated by existing AI capabilities, we must act with foresight. Our responsibility lies in balancing technological progress with human values. Through ethical governance and wise stewardship, we can shape an AI singularity that enhances rather than diminishes humanity, creating a future where technological advancement and humans flourish and evolve in harmony. Thanks for watching. We hope you found the material informative and thought-provoking. If you like this, please subscribe so we can keep you informed on part 2 of this video as well as other content on this topic in the future.